4.4 scatter plots and lines of best fit. The lines of best fit here and scatter plots really has to do with linear equations when we're dealing with positive and negative correlation here, this chapter. So a scatter plot, anytime you plot a bunch of points on a graph, is a scatter plot. So all these different graphs here are scatter plots. What's important to note is a scatter plot can have a trend of the data rising, which is what we call a positive correlation. Positive correlation would be as our x values increase, the y values increase. Okay, so as x goes up, y is also going up. So we had a small y or a small x and a small y, and then we have a large x and a large y, if you think of it that way. So as x increases, y increases. Okay. A negative correlation would be as x increases. So if you're taking note, you may actually want to spell out increases there. Y increases, or y decreases, excuse me. Okay, so as x is going up, y is going down. So notice we start with a large or a small x value, but a large y value, and then when we get to a small x value, we have a large x value, we have a small y value. So as x is increasing this way, y is decreasing this way. And then a no correlation really doesn't have any pattern, any line associated with it. Like we could kind of imagine a slope of a line going downward here, slope of a line going upward here. In fact, let's put some lines in there. Let's see. There we go. Okay. Those are called lines of best fit. A line of best fit kind of shows the trend of the data. So this data is going upward. It has a positive slope, if you think of it that way. A positive correlation has a positive slope to our line of best fit. Okay. This would have a negative slope to our line of best fit. Okay. So these are lines of fit, or line of best fit. You'll see a lot. Okay, and those lines we put in there, they help us to make predictions. Now, obviously, the lines don't hit each point. The lines don't have to go through the origin. That seems to be a common misunderstanding sometimes. They don't have to go through the origin. But when you have no correlation, you can't actually put a line in here. I mean, you can't see a trend going any specific direction. Okay, so let's actually try one of these. The table shows weekly rentals of a new movie. This should be of a new movie. Okay, and the number of weeks since its release. Okay, write an equation that models the movie rental as a function of the number of weeks. So the number of weeks in our movie rental since its release there. Number of weeks since its release. Interpret the slope and y-intercept. Okay, this is a big deal. All right, we're going to interpret. When we're dealing with lines of best fit, we want to always know what we're actually looking at. Okay, anytime we look at linear data, or any data for that matter, and graph it, we want to know what we're looking at. So we're going to interpret the slope and y-intercept. Use your equation to predict how many movie rentals there will be in week 9. Okay. Well, if we look at this, we have to write an equation first. Okay. So when we're thinking of an equation, this is going to be an equation in the form of y equals mx plus b. Okay, we know m is our slope, b is our y-intercept. So one thing I could do is I could plot all these points. You know, I can go 1 and 17, so I'm like right there. Okay, so there we got it. And I can go 2, 13. And 3, 11. 4, 9, 5, 8, 6, lines are, or the points are not in a perfect line there. They almost look like they are. Well, a trend line would do this. A trend line would take that data, and if you're just kind of guesstimating a trend line, just kind of drawing a line that will split the data in half the best you can. You should really use some kind of straight edge to do this. Now I'm on my computer, so I'm going to try my best to use a straight edge I have here. And let's see if I can try this. Now, if you've got a clear straight edge, that will help out tons. So let's see if I can get this here. All right. Looks like okay, that's pretty good there. I kind of bounced around here, but I like to be able to see the x and y intercepts. So here looks, if I can, it looks like, well, my x-intercept maybe 17.25. So if I'm writing my equation y equals mx plus b, I want to know b and I want to know m. Okay, well, it looks like b is about 17. You know what? I'm going to write this over here. Looks like b is about 17.25. I'm kind of estimating there. And, you know, I wrote it over there because I'm going to label this. This is number of weeks, and this is Reynolds. Try to write sideways here. And the reason I'm labeling it, I mean, you should always label your graph anyway, but, okay, is they want us to use x and y in this. And I mean, a lot of times you would make it in context of the problem. You'd maybe say x is w, so you'd say w for x here, and y would be maybe r. So you'd have r equals m times w plus b. But I'm going to stick with what's being asked. Okay, so I've got these labeled, and to find my slope, if I'm doing this, I really need to find 2 points that cross pretty close to perfect. You know. To where the grid line crosses. Let's see, maybe right here is pretty close. I mean, we're almost up to that point, and we're pretty close here. So maybe not quite 2. So maybe if we go like 1.75, going down 1.75 and over 1. Okay, so it would give me a slope of like negative 1.75 and over 1. Okay, which would be about negative 1.75. Now I know I'm being a little picky. I guess I could use negative 2, but what I'm noticing is I'm really approaching 0 here, and so there's a chance I actually hit 0, and so I'm going to try to be as accurate as I can there. So let's go ahead and try that. We got y equals 17.25 x plus, or excuse me, my apologies, I put my 17.25 in the wrong spot. Y equals negative 1.75, that's my slope, x plus 17.25. Okay, and then that gives me the equation that they've asked for. Now it says use the equation to predict how many video rentals there will be in week 9. Well, week 9, I mean, I could kind of look at the graph. This trend line isn't going to give me an accurate prediction completely, neither will the equation, because the equation is based on it, but it'll give me an approximation. So y equals, I'm going to go ahead and use the data I've come up with here. I'm going to put 9 in for x because we're dealing with week 9. I'm going to do some math here. So we get y equals, well, negative 1.75 times 9. Well, if you don't have your calculator handy, you can write it out if you can't do it mentally. So we got 5, 4, 63, 67, and 15. Okay, so looks like 15.75. Okay, so negative 15.75 plus 17.25. And so it looks like that's going to be about 1.5. Y equals about 1.5 All right. 5 means 1.5 10,000s, or I'd have to multiply this by 10,000, which is the same thing as bringing our decimal over 4 spots. So that would be y equals 15,000. So about 15,000 rentals. All right. That's approximately. Okay, now you can actually do a little more accurate measure of that by putting it on a graphing calculator or say like Desmos. So I'm going to go ahead and use Desmos here, and I'm going to put that data in Desmos. In fact, I've already put the data in Desmos for us, but let me go ahead and switch to that. Okay, and so for those of you who don't know how to put data in Desmos, you're going to go ahead and hit Add Item. You're going to hit Table. And in fact, you know what? I'll go ahead and add the data right now, just so we see it. We'll go 1. I think it was 1 through 7 there. So 1, 2, 3, 4, 5, 6, 7. Okay. Desmos is really cool with this. And then our y values. So I think we have 17, 13, 3. No, excuse me, 11. 9, 8, 6, and 5. Okay, so there we've got it. And you'll notice, kind of looking at my picture here, you start kind of seeing the graph up here. So I'm going to kind of zoom out here. So there are my points that I had plotted. If I switch back to my graph, there's those same points. Okay, and what I'm going to do is I'm going to go ahead and put in a line of best fit. And the way to do this is we're going to go ahead and go down to the next line. And we want things to be in y equals mx plus b format. But when I put that, it gives me an error. And so first, I need this to reference my table, so I'm going to drag it up above my table. Second, I need to look at what y is. Well, y isn't called y in my table. It's called y1, so I'm going to put a 1 after this. And x isn't called x. It's called x1, so I'm going to put a 1 there. And now it just changed my table. And so what I need to do is I need to use this little, the similarity symbol. It can be found on your keyboard if you go ABC and then click it here, right there. Or you can, it's usually a shift right below the escape sign on your keyboard. And notice what that did. That put our line of best fit right in there. There we've got it. Okay, and I'm going to scroll out just so we can see everything going up by 1. And so you'll notice it looks like we're at about 17 1/4. Our trend line was pretty darn close to being accurate. Okay, but you'll note that over here in the statistics stuff, they give us parameters, and those parameters, this little m right here and this b right here, those are the more accurate versions of what we're trying to use. So if I'm going to write my equation, and I should have double checked my data, so I'm going to double check it right now just to make sure I had all my points right. 117, 213, 311, 49, 58, 66, 75. Okay, so I've got all my points accurate. This right here is my equation. My equation would be y equals negative 1.89 if I'm going to the nearest hundred, plus, or x, plus 17.43. So I'm going to rewrite that equation here. So let's switch colors. Okay. So kind of in our, so y equals negative 1.8. I believe it was 1.89, so I'll switch back. 1.89, 17.43. Okay, rounding. So notice how close we were. I mean, we had negative 1.75 and 17.25. But this is going to give me more accurate because Desmos is actually using math to calculate your trend line, whereas we didn't use math. We kind of used eyeballing it in estimates. So that allows us to actually do some math here. So we'll go y equals, we'll put in our 9. Okay. And quite honestly, I don't know what 1.89 times 9 is. I mean, I could figure it out. That's 18.9 minus 1.89. But you know what? I've got a calculator right here in Desmo, so I'm just going to type it in here. 1.89 times 9. 17.01. All right, well, perfect. Switch back. So that's going to say negative 17.01 plus 17.43, which means my actual value here would be 0.42. That would be what y equals. Now that's times 10,000. So when I multiply that times 10,000, that is actually 4,200 rentals. Okay, so we were a bit off in ours. Well, quite a bit off actually. Okay, so we had 15,000 there, 4,200. And you know what? Their trend line actually looks a little more accurate too. When you look at it, we're saying, well, it's about halfway there. Okay. Part of our problem is our trend line wasn't completely straight either. It was pretty wobbly, and so we were basing it on a flawed trend line. So if you can use graphing technology, man, that helps out tons. Okay. So there we got it. There's Desmos. Man, that's a really good option. One other thing I wanted to show here is this thing called residuals. If you hit plot, notice it adds a whole column here, but over on your graph, it shows you where your points are moving away, how far away from the trend line they are. So like this point right here, that is up here, that point it's saying is just over 1 unit away from the trend line, above the trend line. This point on this line is just below the trend line. This one is just below the trend line. Below the trend line, okay, above the trend line. These are called residuals. They fluctuate. Our residuals will fluctuate there. It really does help us to figure out how well our line of fit matches up with our graph. The other thing that's important to note is this right here, this R. This R is telling us the closer it is to positive or negative 1, the better our line of best fit is. So for instance, if it said negative 1, these points would be perfectly in a linear fashion. Okay, we'd have a constant rate of change. If it said positive 1, we'd have a constant rate of change sloping upward. Okay, but it says negative 0.97. That's pretty darn close, almost 0.98. That's really close. Now, if it said negative 0.5, those points would be all over the place. Probably not much of a correlation at all there. When you have that bad of an R factor. So you want an R factor up there in the 90s, okay, or up at 1 there. All right. Well, I think that's all I've got. So let me just double check here. Okay. Well, that's all I got for you. Good luck.